This is a review for PC14, Exponential Growth and Decay Scenarios. So the exponential growth formula is y is equal to a times 1 plus r raised to the power of t. And a here represents your starting value, or your initial amount. And t represents time, or the number of years. R is how much we're increasing by. And we'll show you how to use that in just a moment. The decay formula is very similar, but it's y is equal to a times 1 minus r raised to the power of t. And a and t have the same values. A is the starting value, t is the time. So how do you calculate 1 plus r or 1 minus r? Well, if something is increasing by 5%, we always start with 100 and we add, let's say that 5%. So what do we get? We get 105. The second step is to divide by 100. 105 divided by 100. This is a fancy way of just saying we move the decimal place left twice. And we end up with 1.05. So for a scenario that increased by 5%, our 1 plus r, the part that goes here inside the parentheses, is 1.05. We take 100, or we always start with 100, we add 5, we move the decimal place. Similar idea here. If we were decreasing by, let's say, 2.5%, we would start with 100 and subtract 2.5. And here we would get 97.5. Second step is to divide by 100. Another way of dividing by 100 is to move the decimal place left twice. So we end up with 0.975. And that is what would go inside of those parentheses. Let's look at a few examples. Our Yu-Gi-Oh card collection, the starting value is 7,500. We are gaining value, so it's growth. And if we correctly take 100 plus 2.5 and move the decimal place over, we end up with 1.025. And this is per year. So we raise that to the power of t. And I did too much work because it only asks, is this growth or decay? And the answer is growth. We know that from the word gaining value. So over here, depreciating is the key word that tells us we're looking at decay. For the bank account, we start off with 3,200. We are gaining interest, so it's 1.04. 100 plus 4, move the decimal place twice, raised to the power of 12. And we can put this into our calculator exactly like that. And you'll get this. And notice we're talking about money here, so we're going to round to the nearest cent. $5,123.30. Next up, we start with 34,000. We are losing 4%, so we take 100 minus 4, we get 96. When we move the decimal place over twice, 0.96, and our exponent is 18. Since we're talking about people here, we can round to the nearest whole number. So if we put that in our calculator, 34,000 times 0.96 raised to the power of 18, we end up with 16,306.51. This 5 makes that 6 a 7. We round up to the nearest whole number, so we don't cut people in half or anything. On the back, the rent started off at 4,800. It's increasing by 2%, so 100 plus 2, move the decimal place over, 1.02. And how many years between 2010 and 2018? I subtract the 2. I take 2018 minus 2010. And that tells me my exponent. I would round this one to the nearest cent because we're looking at money. Moving to the right, 54,000 is my initial population. I am decreasing, so I take 100 minus 2.5. I move the decimal place over. I get that. And how many years between 2008 and 2020? There are 12. Put that in your calculator, round to the nearest whole number, and there's your answer. Okay, a block of ice loses 30% of its size every hour. What part of the block of ice will still be there after 4 hours? So if it's losing 30%, we take 100 minus 30, and that's 70. We move the decimal place over, and it's going to be 0.70 for 4 hours. And what's our initial value or starting value? One block of ice. So if you put that into your calculator, you'll get the answer. Last one, if something triples in size, well, that's starting with 100%, adding another 100%, and adding another 100%, and we end up with 300. And if we move our decimal place back over, guess what? It's just times 3, because that's what triple means. So 2 times 3 raised to the 4th. That'll tell you the number of bacteria.